Welcome to our video on section 2. We're going to continue talking about area. In this video we focus on trapezoids, rhombuses, and kites. A trapezoid is probably a shape you're not as familiar with. Basically it has two parallel sides. We call those the bases. So we have base, we'll start up here, base 1 on the top, base 2 on the bottom. They have to be parallel. The other two sides are not. Okay, and then the height is still perpendicular to both bases. If it's perpendicular to one of them, it's going to be perpendicular to the other because these top and bottom lines are parallel. So that's just the general shape. Here's the formula. The formula for area says go 1/2 times the height times the sum of the two bases, and I want to show you why that works. This is a trapezoid, and in the top I'm kind of measuring the area. You can see it kind of changes. So we're not really going to use that too much, other than I just want to show you that we can calculate the area, I guess. But what I'm going to do is I'm going to mark that point, I'm going to mark this shape, and then I'm going to rotate it by 180 degrees, and I get this. Okay, and maybe I'll even change this color here so we can see the difference. Okay, so yellow was our original, and green is kind of the new one. Combined, what I want you to notice is that this forms a parallelogram, and we know what the formula for a parallelogram is. Okay, we know that it's just base times height. So if we can figure out what, let me get this set up here, if I can figure out what this whole length is, then I know what the height is, and it's pretty easy to figure that out. So keep in mind, this just rotated 180 degrees, so this part right here is now down here. This whole length at the bottom of the green shape is b sub 2. Okay, so our formula for this, right now, this entire shape would be just the whole base, okay, which is b sub 1 plus b sub 2, and then we have to multiply by the height, and I'm going to put it up here just so it matches. Okay, now that's the formula for everything, but I just want to know the yellow part here, the original trapezoid. And so these are two equal things, I just want half of it, so I put a 1/2 in front, and now this represents the area just in yellow. Okay, so that's where our formula comes from for this one. Okay, before we lose that formula, let's go back to our notes here. I gotta get my mouse. There we go. Go back to our notes. Let's go look at our first example. It says find the area of the trapezoid, and if you notice, we have some markings here. We can kind of tell that this is a base and that's a base because they have these two arrows. That means that they're parallel to each other. And then our height right here is 6. It goes at a right angle, so that's what we're going to be looking for there. So this one's pretty simple. Just kind of plug the info in. Okay, our formula is 1/2 times the height, which is 6. That's a 6, not a b, plus the sum of the two bases. So we have 4 plus 10. So there's a number of ways that you could do this. 1/2 times 6 is 3. And then 4 plus 10 is in parentheses, so I need to think of doing that kind of first. If we follow our order of operations, that's 14. I don't have to multiply the 1/2 times the 6 right away. I just kind of chose to. And so then we just have to do 3 times 14, which is 42. So overall, our area is 42. And just like other problems in this unit, if they give us dimensions, we better somehow label our answer. This is going to be in meters squared. Okay, so that's the basics of a trapezoid. The other shapes that we're going to look at are a rhombus and a kite. So we need to kind of explain what that is. A rhombus, just all four sides are exactly the same. Okay, and then here's a kite. A kite has two pairs of equal sides, and those equal sides have to be right next to each other. So you have, excuse me, we have two things together, two small chunks maybe together on this side, and then two larger chunks together on that side. That's our basic definition of a kite. Our formula here for area is 1/2 times the diagonal times one diagonal times the other diagonal. And it's really hard to see. I'm just going to focus more on the rhombus. But there is a blue line that's kind of going through here. That's one diagonal. Here's the other. If I were to take this picture, okay, take this picture right here, and I rotated it just a little bit, I'd come up with this. And so this is what I want you to consider for just a little bit. I know you don't have that picture on your notes, but pretend that you did for a sec. If I were to very carefully make a rectangle around it, kind of like so, What I want you to note, I can even do this in the same color, this is the height of that rectangle, and this is kind of related. It's like the base. It's the same thing as the base of this rectangle down here. Like that red line should come right down here and match up perfectly. Okay, so the area of the green rectangle, even though it's very poorly drawn, is base times height, and it sure looks like this original rhombus would just be half of that. So we go 1/2 times the base times the height of that rectangle. Really, it's just 1/2 times the two diagonals. Okay, so if we were to try a few questions related to that, question 2 says, what's the area of kite KLMN? Remember, we just looked at a rhombus, but a kite has the same exact formula. We just need to figure out what our dimensions are here. So this is one diagonal, and it looks like that would be 6. Just say 6 in red. Okay, and here's our other diagonal, and according to these dimensions, that one should be 7. Okay, so if we were to figure out the area, it's area equals 1/2 times the product of the two diagonals, so times 6 times 7. 6 times 7 is 42, so if you want to be really detailed, you go 1/2 times 42, which is 21. And again, this is in meters, so we're going to say meters squared. Okay, and our last example, looks like that's about as far as I can scroll down right now, but a rhombus has sides 10 centimeters long. If the longer diagonal is 16 centimeters, what is the area of the rhombus? Okay, I'm going to pause this a second and quick put in a rhombus that I can use to help with understanding this. Okay, so I put in a rhombus. All 4 sides are the same. Let's just mark what we know. We know that the sides are all 10. Okay, and we know that the long diagonal is 16. So there's the long diagonal. I know that is 16. And I'll put in the other diagonal. Okay, we don't know what that one is. Now, if the long diagonal was 16, we don't necessarily know a proof of this yet, but I do know that that's going to be 8. Okay, it's going to split it into 2 equal parts, so that's 8 and that's 8. Now, we have right triangles. We have 4 right triangles there. So if I know that this is 10 and this is 8, I could use Pythagorean theorem to find this. You might also recognize, so I'm going to kind of trust that you know how to do Pythagorean theorem. If not, make sure you ask a question, okay, in class. Make sure you mark that right now if you're not sure how you could use Pythagorean theorem to figure this out. But you might also recognize that this is kind of maybe a well-known right triangle. We have something called a 3, 4, 5 right triangle. That means that one leg is 3, the other one is 4, and the hypotenuse is 5. Or any multiples of that would also work. So since I know the hypotenuse is 10 and this is 8, I could also pretty quickly figure out that this is 6. Okay, and if that is 6, this has to be 6. Okay, so there's a little bit more in-depth thought that you have to do for this particular question. But once we do that, once we figure out the work, now I know my 2 diagonals. One is 16, which they told me already, even though I had to split it up to kind of figure out the question. And now I know that the other one is a total of a length of 12. Okay, so I go back and we'll think of my formula. What's the formula that I know? It's area is 1/2 times the 2 diagonals, so 1/2 times 12 times 16. Certainly you can use a calculator for this if you need to. You can also multiply this in a variety of ways. I look at this, and just to kind of show you my thought process, I want to make that big number really, really small if possible. So I'm going to go 1/2 times 16 first. Doesn't matter the order I multiply them in. So I'm going to leave that 12 alone. 1/2 times 16 is 8. And I realize that still might be a big number for some of you. But if you practice this enough, you kind of start to realize, okay, 12 times 8, I can figure that out. 8 times 2 is 16, so I kind of put that in the back of my mind. I still have 8 times 10, which is 80, so 80 and 16 gets me 96. But that's just, I just thought through it that way. Certainly you may still use a calculator for that if you so desire, and that's going to be in centimeters squared. Okay, jot down a few questions, and we will see you in class.